Hello, we're going to start a unit on polygons. Polygons, we actually learned this definition at the beginning of Unit 4. So just to review, a polygon is a flat, closed figure with at least 3 sides. So any sort of shape, basically, except a circle. So a circle just sort of has one continuous side, but any just kind of shape that has at least 3 sides, no gaps, and it's flat is going to be a polygon. So here's a list of each polygon classified by side along with the name. So a polygon with 3 sides is a triangle, 4 sides is a quadrilateral. Quadrilateral can be lots of different types. It could be a square, a rectangle, a kite, and we're going to get way more into those later this unit. 5 sides is a pentagon, 6 is hexagon, 7 heptagon, 8 octagon, 9 sides nonagon, 10 decagon, 12 dodecagon, 15 pentadecagon. Now, not every single polygon has a specific name. So at some point, once we get into ones beyond the list you're seeing here, we're just going to call the polygon using the number of sides. So for example, let's say I had a polygon that had 33 sides. So we would call that a 33gon. It doesn't have a specific name. So any polygon with a number of sides n, we're just going to call it an n-gon once we get beyond the number of sides that you see in this list. Now, as far as the sum of the interior angles, we studied quite a bit in the last unit that the sum of the interior angles in a triangle sums up to 180 degrees. That should be nothing new. Now, the sum of the interior angles changes depending on how many sides the polygon has. I do not expect or want you guys to memorize this list of numbers you're seeing in the third column of this table. There's actually a formula for this. So if n is the number of sides of a polygon, the sum of the interior angles is going to be found by taking the quantity n minus 2, so the number of sides minus 2, times 180 degrees. So for example, if I have my 33gon and I want to know how many or what the sum of the interior angles is for this 33gon, I would take 33, n is the number of sides, in this case 33, minus 22, and take that quantity times 180. So basically I would do 31 times 180, and I would get 5,580 degrees. I don't know why that won't right. 5,580 degrees. Now, again, I don't want you to memorize that full list of numbers. I want you to memorize this formula right here. So if you have a polygon with n sides, the sum of the interior angles is n minus 2, that quantity times 180 degrees. Now, as far as another way to classify polygons, we have convex polygons and concave polygons. A convex polygon is a polygon in which each interior angle has a measure less than 180. A concave polygon is a polygon in which at least one angle is greater than 180 in the interior. Here's kind of how I tell them apart. I always just kind of say a concave polygon has one side of it that's sort of caving in, and you can see that in these diagrams over here. They each have a side that's sort of caving in, and so I use that to remember that it's a concave polygon. A convex polygon just kind of looks more like your normal shapes like you're seeing over here. If we could flip to the next page, we're also going to talk about exterior angles. We studied those a little bit in the last unit. So the sum of the exterior angles of any polygon is always 360 degrees. So again, this is the sum of the exterior angles. So let's say that this triangle right here, let's pretend that this is an equilateral triangle, which would mean that automatically these 3 interior angles here have a measure of 60, 60, 60, 60. Well, if I sketched exterior angles at each vertex, You guys remember exterior angles just means that you're sort of extending one side of the polygon to the exterior. Well, if you look at these creating linear pairs here, it would be true that 180 minus 60 means that this one is 120. I have a linear pair with the ones at the top. This would also have to be 120 because 120 plus 60 would be 180. And then this one over here would also be 120. Well, you'll notice that those three angles on the outside, the exteriors, 120 plus 120 plus 120 equals 360. You don't have to do this sort of diagram to figure this out every time. It's going to be true that the sum of the exterior angles of any polygon is always going to be 360. So it would have worked out that way whether I did this with a quadrilateral or a pentagon or a hexagon or whatever. Now, a regular polygon. So a regular polygon, what that means is that in a regular polygon, all sides are congruent, all interior angles are congruent, and all exterior angles are congruent. So that's a new definition. A regular polygon has all sides and all interior and exterior angles congruent. So let me try an example about where we would see a regular polygon come up. So it says below is a regular pentagon. So it's a pentagon, which means it has 5 sides. So n is always going to be the number of sides in a polygon. So in this case, 5. And it says, what's the measure of one of its interior angles? Just one. Well, we learned on the other page that the sum of all the interior angles was n minus 2 times 180. So let's start there. 5 minus 2 times 180. So that would give us basically 3 times 180. It would give us 540. Now that's the sum of all the interior angles in this regular pentagon. Well, if the sum of all of them is 540, and if this is a regular pentagon, that means each interior angle is congruent. So if I just divide this into 5 congruent angles, then I'll have my answer. And I get 108 degrees. So what that means is each one of these interior angles here measures 108. Okay. All right. Now it says, what is the sum of its exterior angles? Well, that goes back to this little theorem up here at the top. We don't even have to calculate this. The answer to this question, regardless of the type of polygon, is always 360. Okay? Now it says, what is the measure of one of its exterior angles? There's a couple ways we could do this. We can do it just mathematically. We can also work with the diagram. Well, if it's a regular polygon and the sum of all the exterior angles is 360, well, it's a pentagon, so it has 5 interior angles, 5 exterior angles. So if I take the sum of all the exterior angles is 360 and divide that by 5 exterior angles that are all congruent, 360 divided by 5 is 72. So the answer would be 72. Now, I could have also done that just by simply going back up to the diagram. Like if I draw an exterior angle here, I see it's forming a linear pair with the angle that's 108. And if I took 180 minus 108, that's another way I'd figure out that this exterior angle is 72. And if I wanted to, I could draw them all over the entire polygon. This one would be 72. They'd all be 72. Because they all form linear pairs with the interior angles.